Okay, I'm having a look at some chain, product and quotient rule questions. So the first one we've got here is use the chain rule to find the derivative of these two functions here. So we've got y equals bracket x squared plus 4x to the power of 7. So first I'm going to write this as u to the power of 7. Then over here I'm going to write what u is equal to, and that's the x squared plus 4x. I'm then going to write du on dx, because the derivative of this with the u with respect to x is going to be 2x plus 4. Over here, I'm going to write dy on du, and so I'm saying what's the derivative of the y with respect to u? So I'm saying 7u to the 6. And then I know that my dy on dx is going to equal dy on du times du on dx. Now, if we have a look up here, that's this version of the chain rule that I like to use. You may see other versions of how to write that, and when I do my product rule question, you'll see how I do that a little bit differently to the one in the rule there. So then we're going to put that information back in. So 7u6, we're going to write 7, we're going to put that u back in, which is x squared plus 4x, that's to the power of 6, and we're multiplying that by 2x plus 4. Now we can actually take that bracket away and just write that as, the bracket away, the multiplication, to the power of 6, and just write them right next to each other like that. And there's our answer. Then we've got this one here where we have y is equal to 16 over 3x squared plus 1. So first I'm going to write that as 16 outside of 3x squared plus 1 to the power of negative 1. So that's how I'm going to make this a chain rule question, by making it that power of negative 1. So I'm going to write y is equal to 16u to the negative 1. My u is equal to 3x squared plus 1. So my du on dx is going to be 6x there. Over here, my dy on du is going to be negative 16u to the negative 2. Now I'm going to bring those two together. My dy on dx is going to be dy on du times du on dx. So I have negative 16, I'm going to put my u back in, 3x squared plus 1, that's raised to the negative 2, and I'm multiplying that by 6x. Now what I can do to simplify that is I can put that negative 16 times 6 on the top, so negative 96, and I've got an x, and then I can take this bracket to the bottom and put it to a power of a positive 2. So I'm leaving it with positive indices. For number 2, I'm using the product rule. Now this is where I use a slightly different version to the one up here. What I use for product rule is that y dash is equal to u dash v plus v dash u. It's essentially the same thing, it's just a little bit quicker to write, because what we've got here is our v on dx is the same as v dash. And so we've got u v dash, which is what I write second, doesn't matter order because it's addition here, and then we've got v, and that's the same as u dash, which is what we've got there, u dash v. I just find this format with the u dash v plus v dash u a lot easier. It's what I've always used, and so I find it easy to do that, but obviously you can use whichever format you like. So first I'm going to write my function, my f of x is equal to 3uv, where we've got u is equal to x minus 1 and v is equal to x squared minus 3. So my first step, I need to do u dash is 1, v dash is 2x, and then I'm going to bring it over here. So my y dash is going to be 3u dash v plus v dash u, and I'm going to put my brackets around there because we have that 3 out the front. So I've got 3 outside of, now my u dash is 1, so I really don't need to write that. My v is the x squared minus 3, and then I'm adding to that, v dash is 2x outside of x minus 1. So I've got my 3 at the front. I want to simplify what I've got here in my bracket. So I've got x squared minus 3 plus, and when I multiply that out, I'll get 2x squared, and then I'll have minus 2x. So I can rewrite that as 3 outside of x squared plus 2x squared is 3x squared. I've got minus 2x, take away 3. Now I could then go and expand that out, but it's not overly helpful. On to the second page, we've got a quotient rule question. Now again, I use a slightly different version for my quotient rule as well. So on your sheet, you have got v u dash minus u v dash there, and over v squared. I use y dash equals u dash v minus v dash u over v squared, but you'll see it's the same thing, because here's your u dash being multiplied by v, and then your v dash being multiplied by u. Again, like the product rule, it's just what I'm used to, and I've been doing it for a while, so I'm used to using that format. So over here, we're going to write this as u over v, where u is equal to x squared plus 1, v is equal to 2x minus 3, so our u dash is equal to 2x, our v dash is equal to 2. So now I can put that into that rule, so u dash v minus v dash u over v squared. My u dash is 2x outside of 2x minus 3 minus 2 outside of x squared plus 1 over, and I've got v squared, so that will be 2x minus 3 all squared. I can expand these out to see if I can simplify a little bit on the top. So I have 4x squared, take 6x, take 2x squared, and that will be minus 2. I'm not going to expand this one on the bottom. Now I've got 4x squared, take 2x squared is going to give me 2x squared, minus 6x, take away 2, over 2x minus 3, all squared. Now I could go and factorize that top to see if it would simplify, like cancel out with what's on the bottom. But if I took that 2 out the front, I'm not going to end up with a 2x in my bracket. So I may as well leave that as it is. You might see it with the 2 outside of x squared minus 3x, take away 1, over 2x minus 3 all squared. But that's about as far as you can go. Then we've got number 4, where we're doing a chain rule with a product rule or quotient rule to differentiate. So looking at that, I can see that it's a product rule, and I've got a chain rule inside of that. So I'm going to write y equals u to the 4v, but it's probably easier for me to write that as uv, and then write u is equal to 3x squared plus 1 being raised to the power of 4. Now I'm going to do my u dash as my chain rule, but I'm going to do that in a nice little quick step here. So I know with my chain rule, if I'm doing it the quick way, I'm bringing that 4 down, I'm dropping 1 from the power, and I'm multiplying by the derivative of what's inside. And the derivative of this is 6x. So I can write that as 24x outside of 3x squared plus 1 cubed. Then my v is equal to 2x cubed minus 5. So my v dash is going to be 6x squared. And then I can put that together. So my y dash will be u dash v plus v dash u. My u dash is this 24x outside of 3x squared plus 1 being raised to a power of 3. And my v is 2x cubed minus 5. I'm adding to that, v dash is 6x squared outside of, u is the 3x squared plus 1. And that's being raised to a power of 4. So then you can do some simplifying with that, where we can take out this bracket raised to a power of 3, because the first term has it to the power of 3, the second term has it to the power of 4. So I can bring that 3x squared plus 1 to the power of 3 out the front there. I can also take a 6x out as well. So that means this first term that I've got here, I've taken the 6x out, which means I'm left with 4, because 6x times 4 will give me 24x. And then that is outside of, I've taken 2 of those, so I'm left with 1 there. And then I'm adding to that, I've taken the 6x, so I'm left with an x out the front. I've taken 3 of those. 3, I should have got rid of this one altogether. Sorry, tracking back, I've taken all of those. And so I've taken 3 out of that, which will leave me with the 3x squared plus 1 there. Now expanding this, so I've got 6x outside of 3x squared plus 1 cubed. Then I have 4 lots of that, so I've got 8x cubed minus 20 that I'm adding to 3x cubed plus x. So then I can simplify that. And I have 8x cubed plus 3x cubed is 11x cubed. I've got plus x minus 20. And I can leave it in that format. If I wanted to, I could probably bring that 6x in here just to give me 2 brackets, but that is fine as it is.